Use the cylindrical shell to find a volume generated by rotating the region bounded by the following curves. Y is equal to square root of 4 plus x squared. Then you have y equals to 0. Then you know that x is equal to 0 and x is equal to 4. And you're rotating it about y-axis. You're going to apply the method of cylindrical shell, everybody. Let's take a look at visualization. Before visualize the 2D object, let's see at what value this guy hit x-axis, right? So set y equals to square root of 4 plus x squared equal to y0, right? So if you set this guy equal to 0, you have square root of 4 plus x squared equal to 0. You can raise both sides to the second power to get rid of the absolute value, but it says, hey, 4 plus x squared must be equal to 0. This guy doesn't have a real solution. So, doesn't have a real solution. So what's the meaning of that? It means that this guy never hit x-axis. So let us try our best to visualize this. What is this guy? If I plug in 0, I get square root of 4, which is 2. So at 0, I have a 2. When x is equal to, let's see, for example, 1, I get square root of 5, which is 2 point something. When x is equal to 2, I get square root of 8, right? So the value starts increasing. So the behavior of this object is like this. And if I plug in negative values, I have the same behavior. On the left-hand side, on the right-hand side, but I don't need the left-hand side. I'm just going to graph this guy so you see that what is the visualization of this function y equals to square root of 4 plus x squared. Now, y equal to 0 is basically x-axis. X equal to 0 is your y-axis. X equals to 4 is this vertical line. When x is equal to 4, you get 16, you get square root of 4 plus 16, which is square root of 20. So we expect these to hit at this value. So this is x equals to 4. Very good. So we look at this region. We want to rotate this region with respect to y-axis. So I don't need the rest of this graph, right? Now I'm going to take this guy and start rotating this. So this is the object that I'm getting. Then I'm using some dotted line to give it a little bit of dimension. And let me erase this one. Just did the algebra to show you, hey, it never touches x-axis. So if I rotate this about y-axis, this is the 3D object that I'm getting. The question says, hey, use the shell method. Okay, in using the shell method, we need to figure out what is the circumference of the base and the height, right? Now remember that on top here, you have the square root of 4 plus x squared. And down here you have y equal to 0, which is your x-axis. So if we just take a typical cylinder, just a typical cylinder, everybody, for the sake of visualization. This is the base of the cylinder. We know that the shell method says, hey, the volume is the definite integral of the circumference times the height. And since you are rotating this about the y-axis, it is with respect to x. dx. But for the circumference, down here, you look at the base. What is the radius? The radius, the distance between this point and this point, depends on x. So the radius and x are the same. This guy is equal to the definite integral of the circumference, which is 2 pi times x. If you have a circle, the circumference of the circle is 2 pi r. But here, you have a fixed r value. In this object is moving. X is changing. So instead of r, we use x times the height. What about the height? How do we calculate the height? The maximum y value is located on this graph, square root of 4 plus x squared. And down here, the minimum y value is 0. So the height is the square root of 4 plus x squared minus 0. So that is your height. Minus 0. And then you take the integral with respect to x. We are going back to calculus. To calculate this integral, what is the lower bound? What is the upper bound? My x is changing between 0 and this vertical line 4. So this is the boundary for my x. X is bounded between 0 and 4. Perfect. This is our integral. Now we just need to do the computation, do the calculation. So the volume is equal to the definite integral 0 to 4 of 2 pi x times the square root of 4 plus x squared dx. Let us use u sub. U is the quantity inside your radical, 4 plus x squared. So du is 2x dx. So wherever you see 2x dx, this is your du. This guy is equal to the integral of I square root of u du, or the integral of pi u to power a half du. You can leave it in u form, but make sure to change the boundaries. Otherwise, you can just take the integral and write it in x and then plug in x values. You have pi times u to power 3 halves divided by 3 halves, or 2 pi third u, which is 4 plus x squared to power 3 halves, as x ranges between 0 to 4. And then you can just plug in 4, plug in 0, do the computation. So the volume is equal to 2 pi divided by 3. If I plug in 4, I get 4 plus 16, or 20 times square root of 20 minus, if I plug in 0, I get 4 to power 3 halves, or 2 to the third, which is 8. Very good. We can simplify this further if you want to, or you can use a calculator and approximate this as well. So the options that you have after this, you can simplify this further, because square root of 20 is equal to 2 times square root of 5, or basically use calculator to simplify as much as you can.